Good day, everyone. Today we are going to discuss illustrating and graphing a linear function. So these are the objectives for today's lesson. First, illustrate a linear function. Next, describe the domain, range, intercepts, slope, and the table of values of a linear function, and graph linear function using different models. These are what you are expected after going through this lesson. Now, what is a linear function? A linear function is a function which ordered pairs satisfy a linear equation. Any linear function can be written in the form of y is equal to mx plus b or f of x is equal to mx plus b, where m and b are real numbers and m is the slope of the line, while b is its y-intercept. If m or the slope is not equal to 0, then the degree of the function is 1. If slope is equal to 0 and y-intercept is not equal to 0, then the degree of the function is 0. If both slope and y-intercept is equal to 0, then the degree of the function is not defined. Furthermore, a linear function has one dependent variable and one independent variable. Its graph is a non-vertical straight line. If a function is linear, then it can be represented by a linear equation. Recall that a linear equation can be written in the different forms which are shown in the table in the next slide. So we have here the forms of linear equations. The first one, we have the slope-intercept form, which is y is equal to mx plus b, where m is the slope and b is the y-intercept. The next one is what we call the standard form, which is ax plus by equals c, where a, b, and c are integers and a is greater than or equal to 0. A and b can be 0, but not both at the same time. Then the last form of linear equation is the general form, which is ax plus by plus c is equal to 0, where a and b can be 0, but not both at the same time. When a linear equation is written in standard form, notice that both x and y have exponents of 1, where x and y are not multiplied together, and x and y do not appear in denominators, exponents, or radicands. Now let's have example number 1. Which of the following functions inside the box are linear? So these are the functions. Let's inspect them one by one. Here we have f of x is equal to x minus 2. As you can see, the function f of x minus is equal to x minus 2 is a linear function since the highest exponent of x is 1, and it is written in the form of f of x is equal to mx plus b. So this one is a linear function. Now let's proceed to f of x is equal to 3x squared plus 2x minus 1. When you inspect this equation, the highest exponent is 2. Therefore, the function f of x is equal to 3x squared plus 2x minus 1 is not a linear function since the highest exponent of x is not 1. For equation number 3, we have here f of x is equal to negative 2x. Now this one here is a linear function since the highest exponent of x is 1 and it is written in the form of f of x is equal to mx plus b, where b is equal to 0. The next one we have here, f of x is equal to 2x cubed minus x squared plus 1. As you can see, in the exponents of x, the highest is 3. Therefore, this function or this equation is not a linear function. The function f of x is equal to 2x cubed minus x squared plus 1 is not a linear function since the highest exponent of x is not 1. but rather it is 3. Next, we have here f of x is equal to 2 raised to x minus 3 rather. As you can see, the variable x here is our exponent. Now, when our exponent is a variable, any number could be the value of x. So, from this function, this is not a linear function since it is not written in the form f of x is equal to mx plus b. And for the last example, we have here f of x and y is equal to 5xy. Now, this function is not a linear function since the two variables are multiplied together and cannot be written in the form y equals mx plus b or f of x is equal to mx plus b. Wala, nagbulag si x and y, nagtapad siya, that is why this is not a function. Linear functions can also be presented in table of values. Let's have this example. Verify whether the function described by the given table of values is linear. So we have here table A, table B, and table C. Now, how do we verify if the given table is a function? In verifying if the given table is a function, we need to identify the differences of x coordinates and y coordinates. Now, if the first differences on x coordinates are equal and the first differences on y coordinates are also equal, then the function is linear. However, if the first differences on x coordinates are equal but the first differences on y coordinates are not equal, then the function is not linear. Now let us examine the first differences on x coordinates and y coordinates for table A.
Now, how will you examine the first differences on x coordinates and y coordinates? Simple. You are just going to subtract the values of x from here to here. So, 4 minus 3, that's 1. 3 minus 2, that is also 1. 2 minus 1, that is also 1. As you can see, all the first differences of x are equal. They are all 1. How about y? So, 14 minus 10, that's 4. 10 minus 6, that's also 4. And 6 minus 2, that's also 4. As you can see, all the differences of y, all the first differences of y coordinates are also equal. Therefore, this table of values describes a linear function.
Now let us solve for the first differences on x coordinates and y coordinates for table B.
Let us now examine the first differences on x coordinates and y coordinates for example B. For the table B, we are going to subtract 4 minus 2, that's 2. 2 minus 0, that's 2. 0 minus negative 2, that's 2. While on y, we have here negative 2 minus 1, that's negative 3. 1 minus 4, that's negative 3. 4 minus 7, that's also negative 3. As you can see, the first differences on x coordinates and y coordinates are all equal. Then, this table describes a linear function.
And for the last table that we have, as an example, we have table C. We are going to examine the first differences on x coordinates and y coordinates.
Now, let's proceed to example or table C. Let's examine the first differences on x and y coordinates. So, we have 4. 4 minus 2, that's 2. 2 minus 0, that's 2. 0 minus 2, that's also 2. while 16 minus 4, that's 12. 4 minus 0 is 4, and 0 minus 4 is negative 4. As you can see, only the first differences of x coordinates are equal. The y coordinates are not equal. So that means this table of values rather, does not describe a linear function. Dili ni siya linear function because ang first differences sa y are not the same or not equal.
Now let us proceed to the domain and range of a linear function. If a function is defined by f of x is equal to mx plus b, where m is not equal to 0, the domain D of the function is the set of real numbers and the range R of the function is the set of real numbers. So in symbol, that is presented as D or domain is equal to x such that x is an element of all real numbers, or it can be read as the domain of the function is the set of all x such that x is an element of the set of real numbers. While the range we have here, the range of the function is the set of all y such that y is an element of the set of real numbers. Now let's have an example. Find the domain and range of the following linear functions. Let's have first letter A. F of x is equal to 3x plus 5. Now, since the function is in the form f of x is equal to mx plus b, the domain and range of the function are both the set of real numbers. So in symbols, the domain of the function is the set of all x such that x is an element of the set of all real numbers, as well as the range is equal to the range of the function is the set of all y such that y is an element of the set of real numbers. Now let's have example letter B. We are just going to find the domain and range of function letter B. For example, letter B, which is f of x is equal to 7x. As you can see, only m and x is present while b is missing. That is because b there is equal to 0. So since the function is in the form f of x is equal to mx plus b, where b is 0, the domain and range of the function are both the set of real numbers. So even if b kay na 0 si b dira, it is still a function because m and x is present. So in symbols, that is the same with letter A. Domain. The domain of the function is the set of all x such that x is an element of all real numbers, while the range of the function is the set of all y such that y is an element of the set of real numbers. Now let's proceed to the slope of a linear function. The slope, or m, is usually referred to as the rate of change in y over the rate of change in x. So in symbol, that is slope. So we have here m is equal to delta y over delta x, or change in y over change in x is equal to rise over run. So that is how you find the slope. Now, to find the slope m, you need to determine how much the values of x and y change. Now, to further understand the slope of a function, let's have an example. Now, let's have this example. Suppose the graph has the following coordinates written in tabular form. Determine the slope of the graph. So, we have here the table where the values of x and y are given.
Now, in identifying the slope of the graph with this tabular or table of values, we need to remember that slope is equal to delta y over delta x, or the change in y over change in x, or simply rise over run. But since we are given with the table of values, we are just going to identify the first differences of x and y coordinates to identify the change in y and change in x. So, let's subtract 6 minus 4, that's 2. 4 minus 2, that's also 2. 2 minus 0, that's also 2. 0 minus negative 2, that's also 2. And for the y coordinates, we have negative 4 minus negative 1, that's negative 3. Negative 1 minus 2, that's negative 3. 2 minus 5, that's negative 3. And 5 minus 8, that's also negative 3. Now, since we have the change in y coordinates and x coordinates, we can substitute that one. So, our change in y are these numbers. We can write it as 1, so that is negative 3 over the change in x is 2. So our slope here is negative 3 over 2.
Now let's proceed to graphs of a linear function. Graphing linear functions can be done in any of the four methods. So the first one we have using 2 points. Second one using x and y intercepts. The third one using the slope and y-intercept. And the last one we have using a slope and a point. Now let us first discuss the first method, which is using 2 points. In geometry, 2 points determine a line. Thus, 2 points are enough to graph a linear function. So let's have this example. Graph the linear function f of x is equal to x plus 4 using 2 of its points. Now here are the steps in graphing the given linear function. Step 1, determine 2 points on the graph. Assign 2 values of x, then compute for f of x. Step number 2, plot the ordered pairs, then draw a line that passes through these 2 points.
Now let's graph f of x is equal to x plus 4 using 2 points. Now, in determining 2 points on the graph, we are going to assign values of x, then compute for f of x. Now, you can assign any values, but I want us to consider the values negative 4 and 3 as the values of x. So this is step 1. Now when x, let's begin with negative 4, is equal to negative 4, with the given function, x plus 4, copy, substitute negative 4, so that is f of negative 4 is equal to negative 4 plus 4, f of negative 4 is equal to 0. So this gives us the ordered pair, negative 4 and 0. This is negative 4, this is 0. Now, how about when x is equal to 3? When x is equal to 3, given function is f of x is equal to x plus 4. Substitute 3 to the variable x. So that is f of 3 equals 3 plus 4. The f of 3 is equal to 7. Then this gives us an ordered pair 3 and 7. This is 3 and this is 7. So now we have 2 points. So this implies that the graph will pass through points, this one, negative 4, 0, and second one is this, 3, and 7. Now, step number 2, we are going to plot the ordered pairs. So, our y is 7. First, we are going to plot this one, negative 4 and 0. This is negative 4 and y is 0. Therefore, our first point lies here. This is negative 4 and 0. The second point, that is 3 and 7. The point meets here. So, this is point 3 and 7. Next, we are going to draw a line that passes through this point. So, we are going to draw a line that passes through the 2 points. So, this is now our graph.
Now let's proceed to the second method, which is about using x and y intercepts. Linear function can be graphed using the x-intercept A and y-intercept B. Remember that the x-intercept of the linear function is the point of intersection between the graph and the x-axis and represented by the point A, 0. Meanwhile, the y-intercept of the linear function is the point of intersection between the graph and the y-axis, thus represented by the point 0, B. Now let's have this example. Graph the function f of x is equal to 2x minus 6 using the x and y intercepts. Now these are the steps in graphing a linear function using x and y intercepts. Step 1. Find the x and y intercepts. Recall that in finding the x-intercept, you need to let f of x equal to 0. Meanwhile, in finding the y-intercept, you need to let x is equal to 0. Step number 2, plot x and y intercepts. Then, draw a line that passes through the intercepts.
Now, let's graph the function f of x is equal to 2x minus 6 using the x and y intercepts. Now, in finding the x and y intercepts, we need to recall that in finding the x-intercept, you need to let f of x is equal to 0, and for y-intercept, you need to let x is equal to 0. So, let's begin. Let's have first for x-intercept. For x-intercept, we are going to write the given f of x is equal to 2x minus 6. That is our given. Next, let f of x is equal to 0. So, this is 0 equals 2x minus 6. Next, add both sides by 6. So, this is 0 plus 6 equals 2x minus 6 plus 6. Next is simplify. 0 plus 6, the 6 equals 2x. Negative 6 plus positive 6, that's 0. So, that is 6 plus 2x. Next, multiply both sides by 1/2 to eliminate 2 beside x. So that will become 1/2 times 6 equals 2x times 1/2. So that will become 6 over 2 equals 2x over 2, and simplify. 6 divided by 2, that's 3. 2x divided by 2, that's x. So we have, or that is x is equal to 3. So we have now the x-intercept. Thus, the x-intercept is 3 and 0. This means that one of the points of the graph is 3 and 0. Now, let's solve for the y-intercept. For y-intercept, we are going to let x is equal to 0. So, with the given, we have f of x is equal to 2x minus 6. Let x is equal to 0. That will become f of 0 equals 2 times 0 minus 6. And simplify. So f of 0 is equal to 0 minus 6. F of 0 is equal to negative 6. Thus, the y-intercept, remember this is our x-intercept, and the y-intercept is 0 and negative 6. Hence, another point of the graph is 0 and negative 6. So, these are the 2 points of the graph. Step 2, we are going to plot the x and y intercepts. So, we are going to make a graph. Now, let's plot 3 and 0. So, we have here 1, 2, 3, 4, 5, 2, negative 1, negative 2, negative 3, negative 4, negative 5. This is negative 1 rather. 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Now, our 3 and 0 is here. This is our x, which is 3, and 0 is here. So that's our point, or x-intercept 3 and 0. Now let's plot the y-intercept, this one, which is 0 and negative 6. Our negative 6 is here. Therefore, this is our y-intercept, 0, negative 6. Step 2, we are going to draw. After plotting the x and y intercepts, we are going to draw a line that connects the 2 points. So this is now our graph.
Now let's proceed to the third method, which is about using slope and y-intercept. The third method is by using the slope and y-intercept. This can be done by identifying the slope and the y-intercept of the linear function. So we have here the example, graph the function f of x is equal to 2x plus 1. Now, how will you find the slope and the y-intercept? Step number 1, identify the slope and the y-intercept. Step number 2, plot first the y-intercept. Step 3, find the other point using the slope.
For the third method, using the slope and y-intercept, we are going to graph f of x is equal to 2x plus 1. Step 1, we are going to identify the slope and the y-intercept. Now, as you can see, this is already in function form, or the slope-intercept form rather, which is f of x is equal to mx plus b. As you remember, our m is the slope and b is the y-intercept. We only need to identify the two from the function. So as you can see, we have f of x. Let me rewrite that one. F of x is equal to 2x plus 1. Now, our 2 there, here, is our slope. So, m is equal to 2, while our y-intercept or b is 1. Now, since we have identified the slope and y-intercept for step 1, let us now proceed to step number 2. Plot first the y-intercept. So we need to plot the y-intercept 1, this one. So let us make a graph, a Cartesian plane. Now let us plot the y-intercept. So this is 0 and positive 1. So this is our 0 and this is our positive 1. So here is the location of our y-intercept. After plotting the y-intercept, we need to remember to find the other point using the slope. So we have here the slope, which is 2. Remember, slope is equal to rise over run. And the value of the slope, which is 2, can be written as 2 over 1. Which means rise is 2 and our run is 1. 2 over 1 or 2 divided by 1, that is equal to 2. So this is our slope. Our rise, since this is positive, we are going to go upwards for 2 points. So from here, you need to go up 1, 2. After running 2 points upward, we are going to run 1 time forward. From here, we're going to run here. So that is the location of our next point. That is 1 and 3. Now, since we have the next point, we are going to make a line that passes through the 2 points. So we are going to connect. So this is now our graph.
Now let's proceed to the fourth method, which is about using slope and 1 point. The fourth method in graphing linear function is by using the slope and 1 point. This can be done by plotting first the given point, then finding the other point using the slope. So let's have the example. Graph the linear function f of x is equal to negative 2x minus 3 using a slope and a point. Now, how will you graph this one? Using a slope and a point. Now, these are the steps. Step number 1, find a point from the function. You may assign any value for x in the given function. Step number 2, find another point using the slope.
Now let's proceed to the fourth method using slope and 1 point. So we are going to graph the linear function f of x is equal to negative 2x minus 3. Now, step 1, you are to find a point from the function. You may assign any value for x in the given function. Now, let's do step 1. We may assign any value for x. Let's say x is equal to negative 1. Ikaw bahala. Pero ako, I want x to be negative 1. Then, after having a value for x, let's compute using the given function, which is f of x equals negative 2x minus 3. Substitute the value of x, which is negative 1. So that will become negative 2 times negative 1 minus 3. F of negative 1 is equal to negative times negative, that's positive 2. 2 times 1 is 2 minus 3. F of negative 1 is equal to 2 minus 3, that's negative 1. Therefore, the line passes through the point negative 1 and also negative 1. Our x is negative 1, which is this one, and our y is also negative 1. So this is our first point. Now, step number 2, we are to find another point using the slope. So, slope atong gamiton. By inspecting with the given function, f of x is equal to negative 2x minus 3. As you can see, this is in a slope-intercept form, mx plus b. Our slope here is negative 2. So, since our slope is negative 2, that can be written as negative 2 over 1. Therefore, our rise is negative 2 and our run is positive 1. Now, let us plot, since we have step 1 and step 2. Step number 3, we are going to plot. Now, let us plot first this one, the point. So, we have negative 1 and negative 1 that meets here. So, therefore, this is our point. Negative 1 and negative 1. Next, we are going to use the slope or the rise over run. Our rise is negative, so we are going to move 2 units downward since this is negative 2. So from here, let's go. Let's move downward 2 units. 1, 2. And our run is 1. So we run forward 1 unit. So this is the second point. So this is 0 and negative 3. So, since we have the 2 points now, we are going to make a line that passes through the point. So, i-connect lang nato silang duha. Since we have connected the 2 points, this point and this point, we now have our graph.
Now let's have the related problems on linear function. Linear function has varied applications to real-life situations such as the concepts of rate of change and direct variations. Now, in order to deepen your understanding with related problems, let's have an example. So we have here the example for related problems on linear function. Fernand drives a motorcycle going back to his hometown. He traveled an average speed of 60 kilometers per hour. Now, first A, make a table that relates the number of hours he traveled, that is x, and the distance he covered in traveling, or that is f of x. B, write the linear function that describes the given problem. C, what would be the distance he covered after traveling for 4 hours? And D, if his hometown is 330 kilometers away from his starting point, how many hours should he travel? And last, sketch the graph that describes the function.
Now, let's answer letter A. Make a table that relates the number of hours he traveled, or x, and the distance he covered in traveling, or f of x. So, we are going to make a table. Since this is 60 kilometers per hour. That means 1 hour is equal to 60 kilometers. So, we are going to make a table out of that one. So, this is letter A. X and f of x. So for 1 hour, which is the hours he traveled x, for 1 hour, he traveled 60 kilometers. For 2 hours, let's times it. Times ra nato si 60 og 2, that's 120. For 3 hours, si 60 times of 3, that's 180. So that is the table for letter A. Now let's proceed to letter B. Write the linear function that describes the given problem. Now, in writing the linear function that describes the given problem, we need to recall the concept of finding the linear equation given 2 points. So, from the table, we are going to consider 1 and 60 to be the first point and 2 and 120 to be the second point. So, that is, let's solve for letter B here. So we are going to solve letter B. Remember, our first point is 1 and 60. And the second point is 2 and 120. So we are going to use the formula y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1. This is the formula that we are going to use in identifying the function that describes the given problem. So this is our x sub 1, y sub 1, x sub 2, and y sub 2. Now let's substitute. So this will become y minus 60 equals y sub 2 is 120 minus 60 over 2 minus 1 times x minus our x sub 1 is 1. So that will become, this is our, remember this is our formula. Next, you are going to substitute. After substituting, you are going to simplify. So y minus 60, 120 minus 60, that's 60 over 2 minus 1, that's 1. Times x minus 1. After simplifying, you are going to distribute, or you are going to apply distributive property. So you copy y minus 60 equals, you distribute 60 times x, that's 60x. 60 times negative 1 minus 60. You can write over 1 or pwede na wala. Okay, kung imo siya i-divide 60 divide 1, that's still 60. Okay, so next you are going to apply addition property of equality. Meaning you are going to add 60 on both sides. So, y minus 60 plus 60 equals 60x minus 60 plus 60. Anong i-add na tog 60 both sides para ma-eliminate si negative 60, mabalhin siya on the other side. Now, let's proceed. Negative 60 plus 60. Negative 60 and 60, that's 0 also. So, ang nabilin, si y equals 60x. Therefore, you can write that as f of x is equal to 60x. Now, this is our function that describes the given problem. This is the function that describes the given problem. We have now answered letter B. Let's proceed to C. What would be the distance he covered after traveling for 4 hours? So we are going to solve for letter C. Now, to find the distance he traveled after 4 hours, we are going to use this function. So we have f of x is equal to 60x. This is the given function. Now, we are looking for the distance he traveled after 4 hours. So, substitute 4 to x. Substitute 4 to x. So, that is f of 4 is equal to 60 times 4. And next, you are to simplify. F of 4 is equal to 240. Thus, or therefore, the distance traveled by Fernan after 4 hours is 240 kilometers. Now we are done with letter C. Now let's proceed to letter D. If his hometown is 330 kilometers away from his starting point, how many hours should he travel? Now, to find the number of hours needed to travel 330 kilometers. So, for letter D, we are going to find the number of hours needed to travel 330 kilometers. So, we are going to use the same function, this one. So, f of x is equal to 60x. That is the given function. Next, you are going to substitute the given 330 to f of x. So, this will become 330 equals 60x. Next, you are to divide both sides by 60. Why are we going to divide both sides by 60? I-divide na to both sides by 60 kay para makabalota sa value ni x. Mawala ang tapad ni x na more than 1. So, 60 divided by 60, that's 1. So, ang nabilin is only x. 330 divides 60. That is, let's use our calculator. 330 divided by 60, that is 5.5. Or, x is equal to 5.5. Thus, or therefore, Fernan should travel 5.5 hours or 5 hours and 30 minutes to reach his hometown. Now we are done with letter D. Now let's proceed to the last one. Sketch the graph that describes the function. So we are going to sketch the graph. How are we going to sketch the graph? We are going to use the table of values. So for letter E, let's copy the table of values. For letter E, we are going to sketch the graph. Now the table for values is this one. 1 is equal to 60, 2 is 120, 3 is 180, 4 is 240. For our Cartesian plane, let's say this is 1, 2, 3, 4, 5, negative 1, negative 1, negative 2. Let's say our y values we have here, we're going to use the multiples of 60, 60, 120, 180, 240, 300, and 360. Now, as you can see, the first one we have is 1 and 60. So 1 and 60 is here. The next is 2 and 120. 2 and 120 is here. Next is 3 and 180. So 3 and 180 is here. The last one we have 4 and 240. So 4, 240 is here. Now, let us going to connect the coordinates or points. Let me rewrite that one. So this is now our graph.
Since we are done with our discussion with our lesson today, let us now have an activity. So we have here activity number 1. The box below contains 4 linear equations in standard form and 4 linear functions. Your task is to match the given linear equation to its equivalent linear function. Then, determine the slope, the x-intercept, and the y-intercept of each equation. Write your answer in the following table. So you are going to identify the linear equations and the linear functions. You are going to match the linear equations in the form ax plus by equals c to the linear function f of x is equal to mx plus b. And after that, you are going to identify the slope, the x-intercept, and the y-intercept. Now, this is activity number 2. Complete the table below by finding f of x given the values of x. So here are the functions. You are going to identify the value of f of x given the different values of x. Then you are going to complete the table of values. You may pause this video so you can read and understand each statement or each functions. So that ends our lesson for today. I hope you have learned something and see you in our next meeting.